Okay, now we apply the same scheme to calculate the determinant of the 4 by 4 matrix that you see here. We're going to go across the first row. We're going to get the minor corresponding to each element of the first row. We're going to get the cofactor, which is easy to get by the determinant of the minor and the -1 to the I plus j. And we're going to multiply each of those determinants by whatever number is in that particular position on the first row. Okay, so let's see. We start with the 1, 1 position. So this would be -1 to the 1 plus 1, -1 to the I plus j, times 2, which is this number, times the determinant of the minor that we get. Well, we throw out the first column in the first row for the 1, 1 cofactor, and we have then the determinant of the matrix that we have left, the 7, 2, -6, 1, 9, 1, 2, -4, 7 matrix. Okay, of course, how we're going to calculate this determinant? We're going to have to do 3 more cofactors times the 3 numbers across the top row. So there's still 3 more 2 by 2 matrices just to calculate this matrix. Okay? Then, though, we go on to the second number in this row, which is 1. So we take 1, we multiply that by -1 to the 1 plus 2, because that's what you do for the cofactor, and by the determinant of the minor that we get when we throw out row 1 and column 2. And then we go to row 1, column 3, -5 times -1 to the 1 plus 3, because it's the 1, 3 cofactor, and the minor that we get for the 1, 3 throughout row 1, column 3, we have this matrix. And we do the determinant of that matrix. And then the 1, 4. This element here, that's the 3, that's the 1, 4 element. The -1 is raised to the 1 plus 4. We multiply by this number and by the determinant of the minor that we get when we throw out row 1, column 4. This matrix right here that's repeated down here. Okay? So that reduces the 4 by 4. The problem of evaluating the 4 by 4 basically to the problem of evaluating 4 3 by 3s. And of course each 3 by 3 is obtained essentially by evaluating 3 2 by 2s. So we're ultimately going to have to do arithmetic with the determinants of 12 2 by 2 matrices in order to get this one. Well, you could do that. You know, you could write all that out on a page if you write fairly small and neatly. Be a bit of a pain, and you wouldn't really want to do it, but you could. In a reasonable time, you know, you'd probably make a mistake. So, you know, most of us would be unlikely to do it accurately, but we could go through the process probably in 15 minutes. Okay. What if we wanted to do a 5 by 5? Well, then we'd have 5 numbers across the top row, and of course we'd have 5 rows. Okay, 5 numbers across the top row, and each minor would be a 4 by 4 matrix. Okay, so we would have 5 4 by 4 matrices, and each 4 by 4 matrix comes down to having to evaluate 12 2 by 2 matrices and do a little bit of arithmetic with them. So that's going to be 60, 5 times 12, 60 2 by 2s to do a 5 by 5. By the time you get up to a 10 by 10, you're going to end up with about 1 million calculations, okay? And by the time you get up to a 20 by 20, you're going to end up well into the tens of trillions of calculations. Impossible for a human being to do in a lifetime, okay? So you wouldn't want to use this actual method to calculate your determinants, but this is the definition. And we develop shortcuts. One shortcut that I've already mentioned is for a 5 by 5, rather than trying to do 62 by 2 matrices and all that arithmetic, you could probably reduce a 5 by 5 matrix in 15 minutes. Keeping track of the elementary matrices, mainly keeping track of their determinants, and then just multiply those determinants. Okay, actually you have to multiply by the determinants of the inverse elementary matrices, but in most cases that's the same as the determinant of the matrix, except for the matrix you get when you multiply a row by a number, and then you have to multiply by the reciprocal, and the determinant would be the reciprocal. Okay, and you know, if you work on this stuff a little bit, you'll understand exactly what I ran together there. Otherwise, don't worry too much about it. Just by reducing and keeping track of your elementary matrices, it's much easier to get the determinant that way. Okay, there's one more special matrix, an upper triangular matrix, which I wrote pretty poorly, and we'll talk about that in a minute. It's very easy to get the determinant of an upper triangular matrix.